the second subtopic. Right, for nuclear energy, so last time we have looked at what is fission reaction and then fusion reaction. Okay, and you need to know about in nuclear energy, we also learn about nuclear reactor. Nuclear okay. So for nuclear reactor, okay, this is important. First, you need to know the structure. Yeah. So we have number one. Okay, so the process, and then the process. Okay, from one, then go to 2, 3. Okay, what happened at 3, and then 4, and the fifth one, the fourth one, fifth one. Okay, and then you need to know this one, the reactor. What do we have here? Okay, so those are control rod. Okay, so what's the function? The control rod controls the reaction rate. How? By absorbing excess neutrons. Yeah, so we have neutrons here. So the excess neutrons is absorbed by the control rod. So you are expected to know that. And then we have moderator. Yeah, this one. So what's the function of a moderator? It slows down the fast moving neutrons. Okay. Okay. Right. So we need to have neutrons which moving slowly. So in order to slow down the fast moving neutrons, we need a moderator. Okay, and when that happens, nuclear fission can occur. Right? So, and then moderator. What is the best type of moderator? So usually we use graphite or water. Okay. And then what are the safety features? So you need to know the safety features. Right, first we have concrete wall around. That is to prevent leakage, leaking into the surroundings. And we have water for cooling agent. So you just remember structure 1 and 2. These are for the safety precautions, safety features. So water as cooling agent is to absorb heat energy from the chain reaction. And that this process, condensation generates steam. So this steam is needed here to steam channel to the turbine. Then what happened? Turbine is rotated because of the steam is in high pressure. So the rotation rotates the magnet or coil in the generator. So we have generator here. So the generator will rotate because the turbine rotates. And then that's how we get electrical energy. So the change of energy, the energy from the nuclear fission or chain reaction here converts the heat into kinetic energy. Then that kinetic energy then transferred to electrical energy. Right? So you need to know the process. Then we look at a few example questions. Okay, we are going to answer this question. Which one? Okay, diagram 9 shows. Okay, before let's recall first what we have learned last time. Okay, the following equation shows the radioactive decay of a nuclide X. So where is the nuclide? So this is X. What is the meaning of radioactive decay? So what is radioactive decay? So radioactive decay is a process. So radioactive decay is a process. Process of unstable nucleus becomes more stable. How? So ada 2 points. By emitting radioactive radiation. Okay? And then if you state radioactive radiation, we know you are talking about alpha radiation or beta or gamma radiation. So enough saying radioactive radiation. Another easy question. Name the radioactive radiation released in this radioactive decay. So we see this symbol. Yeah, this symbol means we have beta particle, because we know beta particle is an electron. Compare the stability of nuclide X and Y. So you see X and Y. Okay, X is before the arrow, Y is after the arrow. That means Y is the one after decay. So Y is more stable than X. Because the process unstable becomes more stable. So this one stable, less stable. What happened to the proton number and the nuclear number of nuclide X after the decaying process? So look at proton number. Okay, so okay. Right. How do you need you need to look at this one. Look at the emission. So the emission electron is emitted. So the neutron atau the nucleon is 0. So no change. So you have to maintain the value here, the proton. So let's say here proton is A. Not the proton, sorry. Nucleon. I mean nucleon. So if the nucleon here is Z, this one should be Z also. Because Z is equal ni after lah macam ni kan. Z equals to Z plus 0. And then if we have a proton at X, so Y also has A. Okay. So A is equal to A, but we have -1. So if A equals to A minus 1, so what is A? So that is incorrect. So you have to make sure you have like this. A is equals to something that you don't know. Let's say P plus minus -1. So if we let's say if P is any number, let's just try. So let's say P is 2. So what is A? A equals to 2 plus minus 1. So A is equals to 1. So 1 is less than 0. Alright. So for the proton, Proton is increase by 1. So here only 1, and after the decay process, proton becomes 2. So increase. Then you mention lah how much increase. Increment 1. Nuclear number. So the answer, what's the answer? Yep. Nuclear number is unchanged. Maintain. Alright. Easy. Okay, calculate then. Okay, so look at question number 2. Diagram 1 shows a nuclide, thorium-234, is placed in a container. Thorium-234 nuclide decays to a nuclide radium-226 by emitting alpha particle and beta particle. Mark for the correct answer in the box provided. The box in diagram 1 made of... Okay, so this one, the box containing thorium-234, and there is a symbol hazard kat situ. Okay, so you know that we must keep radioactive substance must be kept in a thick container. Okay, if it's not thick, then we need to have lead. Now, calculate the number of alpha particle and beta particle that emitted in the thorium-234 decays. Okay, if you look at the question, it states here, thorium decays to, so we have thorium decays to radium 22688. Okay, by emitting alpha and beta, so plus alpha plus beta. So that's it. Okay, we know this from the question. That's why you must read the question carefully. So the question says here, calculate number of alpha particles. So first and foremost, you have to write this. And then you have to complete the equation. Okay. And we want to know what is this value here. Let's say A. This one B. We know this one. Alpha. Okay. We know an alpha is what? An alpha is a helium. Helium has 4 and 2. So we change alpha into helium. And we know that helium has 4 nucleon, 2 protons. And beta is an electron. And an electron has 0 and -1. Now let's check, are they in balance? So 234 plus nothing next to the thorium. So 234 equals to 226, this one, plus 4. We don't know how many 4s do we need. So let's say we place an X here, a Y here. So plus 4X plus 0y, which is 0. So from that equation, 4x equals to 234 minus 226. Okay, so that's 8. Therefore, x equals to 2. So this is on the left hand side. This is on the right hand side. So the x is a 2. Okay, next. We do the same, and then now we want to know what's y. So the only thing we need to look at the proton part, yeah, because this one is already 0. Yeah, so that doesn't help. So we do the calculation on the left hand side. That's 90 equals to right hand side 88 plus 4 minus y. Yeah? So therefore y equals to 2. So so the question asks you, you cannot leave your answer like this. So what's y? What's x? So you just write something like this lah. Okay, so we have 2 alpha particles and 2 beta particles. So that's the answer. C, thorium-234 has half-life of 20 days. Okay, so from here we know that half-life is 20 days. And initial mass, the original, is 48 grams. Calculate the mass undecayed. So if this is decay, okay, this is the first one, 100%, 1. Okay, so after it become half, so this is present. And we lost another 50%. Okay, question does not want the decayed, not this one. It wants the undecayed. So that's simple. So what you need to do first, okay, so we start with the original initial mass, which is 48 grams. Okay, so the question asks you after 60 days. So check first. So how many times, how many cycle it has? So for 60 days, and each cycle is 20 days. So we need 3 cycles, 3 times. So 1 time, 2 time 3. So this is the half-life, first half-life, second, and the third half-life. So 48, half of 48 is 24 grams. Half of it is 12 grams. And half is 6 grams. And that took 20. Each of the half-life is 20. Therefore, the mass and the question, look back at the question. Therefore, mass undecayed is 6 grams. Okay. Can you use formula to answer this one? Yes. Alternatively, you can use formula, which is very simple. So this is the formula to the power of n. N is how many times? And times with the initial value. So half, 3 times. We calculated this one already, so we know 3. And times with 48 grams. So that gives us